Thank you to PCBWay for sponsoring this video and providing some interesting parts. However, I am a little bit worried about these because this box has arrived from the shipping kind of squished and the parts in here are very thin. However, PCBWay seems to have done a good job of packing these, so let's take a look. Here we go, some fancy custom tool steel saw blades. These were designed to be as CNCable as possible, effectively, but they are really thin. They're less than 1 millimeter, and I'm not sure how well that's going to show up on camera. And actually, they've survived the shipping process pretty well, considering that they are this thin and the box got crushed in transit. I am really, really happy with these. I cannot wait to try these out. Hello everybody, I am Ben from Team Panic. So yes, we are going to be doing a brand new version of Vogon Poetry, the overhead saw robot, to go with those very, very nice saws you saw at the start there. So we're not going to be doing a testing on any of this until we get a new version of Vogon Poetry rocking and rolling. And we're doing this to fix one particular component which is causing a couple of issues. And that component is the mechanism or the servo that is required to do the raising and lowering, or is currently being used to do the raising and lowering. It's these tiny little things here. These are a 5.5 gram servo that take full 2S voltage directly into them. So they don't need a beck or anything like that in the robot. However, they have a couple of issues with them. First of all being that they are only a 90-degree servo, which means that the full range of motion I get out of them is down and up. That's it. So I cannot self-right properly by just like dropping the weapon over the back and pushing myself back up the way you would normally self-right. And the other problem with them is that they crack and they break. Like this one that I have in my hand here, where one side has split down the middle from the force of trying to raise and lower the hammer. Now, these were put in mostly because they are a very, very lightweight solution, and of course, they don't need an ESC or anything, they don't need a beck, they are literally just a self-contained solution to raising and lowering the arm, and of course, they are 5 grams. That's nothing. However, constantly having to replace these and not being able to self-right with this robot has led to a lot of issues with this robot. Lots of shots on the underside, lots of things like this where I have got stuck and then had the dustpan ripped off entirely. So it's time to update and change that. And unfortunately, anything we change this to means adding extra weight to the robot, which means we have to rip weight back out. And what I'm actually looking at doing is I am looking at using one of these. This is an N20 with a worm drive set up on it, so it cannot be back driven, which I'm hoping is going to help, but also I'm hoping that we can just like stand it up, and that means that we can lose some weight by taking out these front 2 posts here, which hold everything up and in place. But I fear that's not going to be enough. So, I mean, you've seen the title of this video and you've seen the thumbnail. We're going to attempt to make this entire robot out of HDPE, or as near enough as possible. So that's what I've been using for the front armor, and 2mm HDPE up the front here has been ridiculously strong, and I think that we should be able to make an entire chassis out of that. So let's fire up my new little milling machine for one of the most complicated jobs I've ever done with it. And honestly, I was a little nervous setting this job off. It was a long job. This took 3 hours to complete, which is crazy. It's about actually the same as printing the chassis would have taken, which is interesting. Usually CNC is faster, or at least for the CNCing I've been doing. And yeah, thankfully though, it seemed to go off without a hitch. It was doing the pocketing in 1mm drop down sections, which seemed to work just fine for this particular bit that I'm using. And I'm pretty happy with how the machine performed. It did leave a lot of mess though. And here we go, this is the chassis, or most of the chassis, off off the CNC machine. Now, I do have a block of HDPE that I could have used to machine the entire thing as a billet. However, that just felt really wasteful and it was going to take a lot of time. This piece already being CNC'd from 6mm thick took about 3 hours, as I mentioned, and if I'd been CNCing out of a 30mm block, I would have reduced even more material into chips, and I wouldn't have been able to get a nice bent back area or curved back area, which is what we're going to do here in half a second. This is it off the machine, almost off the machine. It was a little bit scragglier than this. I have been cleaning it up. I wanted to do the cleanup on camera, however, it is actually kind of fun to just pick at this and pick off the leftover straggly bits of HDPE. So I've been kind of slowly doing that as I've been setting up shooting in different bits and pieces here through the day. The other thing I will say about this is things are very, very thin. The front wedge here, on this side where the height setting was correct, it's 1.5mm. Over this side, it's probably about 1mm or a little less than 1mm because my machine's not perfectly trammed in and everything, so the stock sits higher on one side and gets cut more, and gets cut more. That's how that works. The middle section where all the electronics go is 1.5mm-ish, roughly, and then the back section out here is 2mm, and we're going to bend this up to form the back like we have on this guy, this kind of nice triangle shape so that we don't get stuck on our back. Also, yes, you can see here, this has got a large section of glue here because this is all 3D printed and it's 3D printed in this orientation. So being hit by a horizontal along the back just splits the layer lines and then you end up with rapid repair jobs in the field. So hopefully by having some solid HDPE bent into shape, we will actually be stronger than we have been before. And there we go, that is them. We've got more parts ready to go. Now, in the original version, we have a double supported mechanism. In this version, again, for weight-saving reasons, I'm trying to just run the weapon arm directly off the motor. So we're gonna see how that goes. But I did still leave the 2 mounting locations because I want to support the motor mount with a little like right angle support like this. Whoops, and that's gone flying. I'll go grab that in a second. But as you can see, things just kind of slot together right now and don't slot together very well. Well, they slot together okay, and there's a little bit of play in it, but not too bad. This is HDPE. Nothing sticks to HDPE. You cannot glue HDPE together. You cannot acetone weld it, anything like that. So instead, we're gonna have to drill into this and then put some wood screws in to secure everything in place. And so there we go, that is our motor mount done up. That's a little interesting, but it seems to be working. It's holding the motor pretty firmly in place. I can't pull it out by hand. If things in testing seem like it's gonna be a problem, we can always put an extra piece across the top to really trap the motor in between these 2 sheets. But for now, I think that's actually gonna do exactly what we need it to do. So the next step is, of course, to drill some holes and put some bolts in to hold it this way. So with the back bent, I also went ahead and drilled and put in 2 screws to hold in the weapon arm, and actually all the wobble is gone. Like there was a little bit of wobble in this before, but this is like the wobble in this now is actually the chassis flexing and nothing else. So with the front armor on, which we're just gonna pinch this front armor, it's held up pretty well. This actually may hold up a lot better than I was expecting. I might still put in this extra little piece down the front here, just to kind of really round everything out and hold it all together really nicely. But it actually is a lot stronger than I was expecting, just like this. So that is pretty cool. I have an idea for wiring it up, and I'm actually going to borrow the ESC out of one of these, which I have actually got one already that I've hacked ready to go as a 360 servo. So that should work okay, I hope, because if I don't really have weight for anything else. So we're just gonna have to go for it. But yes, we have everything ready to go. I've even drilled some extra holes in here for the motor mounting, so that should be all good. We now just need to borrow / take all of the components out of the old version of Vogon Poetry. So that is basically all the HDPE together. I do think I want to do a HDPE top plate as well for this. It actually is pretty rigid now that everything's kind of locked in. The only real problem at the moment is this, that you can see my finger between the little exits down here, because this front armor is actually a little bit too big. I probably need to recut and rebend this at some point, but I don't have time right now, so we're going to forge ahead with this as it currently exists. We're going to get a new motor mount. The new motor mount will actually just be 3D printed because I need to lock onto a D shaft, and that's way easier to do with a 3D print than it is with my current mediocre CNC skills. So we'll do that, and then yeah, I need to wire this motor up, and then I think we'll almost be ready for a test. Okay, here we go. Let's try this out now. So I have my 3D printed arm on. I also have the new hacked servo in. I've connected up a battery, so no weapon right now. We are just testing out to see if this works. So first of all, we will do drive. So that's drive, and the arm has gone down, but I didn't touch anything. Oh, that's interesting. That shouldn't be doing, I don't know why that's doing that. It should just be going in a direction when I tell it to go in a direction, but it seems to be getting feedback somehow, which shouldn't, okay, I need to do something other than this hack servo because apparently that doesn't work. All right, time for take two. This time using a hacked off DF robot motor ESC. We'll see if this works. It was working. The ESC was working before. Okay. What? It's making sound when I move the stick, but not actually doing anything. Ah! Okay, so after a bunch of testing, including putting external power on this motor, it seems like this motor's got like a weird tight spot in it, or maybe it's got some gunk somewhere in the motor, because at certain points, it doesn't matter how much power you put across the output, it just seizes up. And I think that's what the DF robot motor was, ESC was seeing, because, well, hopefully, this is the new one. Let's see if this does the things. Okay, well that's an improvement, but I think the arm might actually be too tight now on the gearbox. So let's try and fix that. Okay, so trying this again. There's still some weird like tight spots in the travel, and I'm not sure what that's about. Okay, I've worked it out and I'm going to try and show this to you as best I can. It's going to be a little bit difficult here. But, so these are worm gear motors. That's how they've got the output at a 90-degree angle from the motor, which is a thing that I wanted for this design so that I could have the motor straight upright. And you've seen the design. It makes everything compact. It helps. It works. However, playing around with this, realized there's a fair amount of slop in these gearboxes. And I was thinking that it was this slop that was the problem. Unfortunately, it's not the problem. The problem is that if you put too much torque, the worm gear rises up. And you can just about, I hope I'm getting at least one good one of the worm gear moving. What this means is the shaft of the motor is moving, and it's moving away from, like, up out of the motor, which means that the connections on everything are starting to not work effectively, because the other end of that shaft will be connected to where the brushes are connected to, which is where the power comes into a brushed motor. It's also moving the coils out of the magnets, which means a reduction in torque. And so this is what was happening when the arm was adding torque to the motor in the wrong direction. When the motor arm was hanging off the back of the robot, it was dragging the worm gear out of the motor and thereby dragging the shaft out of the motor and thereby reducing the torque of the motor, making it less efficient to get power into it. Just a whole lot of bad, unfortunately. Yikes! Well, that is a fatal flaw in this design then, because it kind of relies on having those worm gear motors to have that right angle shaft on them so that the mass of the actual motor is down and it doesn't make the whole robot really, really top heavy. I mean, it's already kind of top heavy with a saw on the front. So that's just unfortunate in a lot of ways. And I have a pack of 10 of those motors. All of them do the same thing. All of them kind of shift the drive shaft out of the motor when you put the wrong amount of torque on them or in the wrong direction, effectively, which is not good. Having said that, I have still gone ahead and finished up the robot for two reasons. One, I really wanted to see how these brand new tool steel saws work, because they are only 0.7 millimeters thick. They are not very thick at all. And I did that mostly for weight saving, but also because I think it will give me a better cut, or at least I'm hoping it will give me a better cut. And the other one is weight. I wanted to see how we went with the new chassis, with the HDPE chassis. And I don't know how I've done this, but we have done a spectacular job here. So I have moved from the tiny little servos, which are 5 grams, to this worm drive motor, which is 12 grams, and somehow I've dropped 15 grams out of the chassis. So I was expecting to be going up in weight and having to come back down again. This whole system, as it stands with the new saw blade on it and everything, is 136 grams, which means I've got 14 grams left to play with. I could put a bigger saw blade, or a thicker saw blade on, or a saw blade that doesn't have quite so many aerated cuts in it. I could actually put the old saw blade back on, but that's not what we're here for. We're here to put on the new saw blade and see if I can do custom saw blades with the help of PCBWay. I'm excited by this. It also means I can actually probably go back into the CAD and change the thicknesses of some of the stuff in the HDPE chassis. I can make everything 2 mil, including the front dustpan, which will help a little bit because, again, it is a little bit flimsy on one side. But I'm running out of time for things, so we are just going to put this into the test box. Okay, so yes, these saw blades are nasty. Like, that is ridiculous. It's cut all the way through this chassis. I mean, it is a bit of a thin chassis and it is just ABS, but it cut through that no problem. And my favorite thing is, yes, the arm got stuck down, like I couldn't get it back from this position because, again, putting that torque on it forces the worm gear out, so when it's trying to lift up, it's just failing effectively. But you saw in that testing footage, it didn't matter because this saw has enough bite. It was just like dragging this chassis into itself, which is how I got this very nasty cut on the bottom here. And that was it, just like, I just left the saw go and it did that on its own, which, oh, this is very, very cool. It's such a shame about this bloody worm gear because if it wasn't for that, we would have a very, very nasty saw on our hands. I have a competition literally in a day and I might see if I can fix this problem before then, but I think it's unlikely. So we're gonna have to do that for the next time we run Ants A's. Anyway, that is gonna be it for this video. I hope you have enjoyed that one and I will see you in the next video.